So now in this program I'll show you how to basically use this malloc in order to allocate memory dynamically. So first include the header file, okay, and also include malloc.h header file, okay. In the main function, so first consider the pointer called star iptr, okay, and then I is a loop variable, then n is representing a number of elements that you want to store, okay. So I'll just prompt the user to basically enter the elements. So enter number of elements, okay, and using scanf statement we can read n value here, address of n. Now using this printf statement we can prompt like this, enter %d elements, okay. So that is n number of elements you have to enter, okay. So now using for loop you can read those elements like I equal to 0, I less than n, I plus plus, and using scanf statement, okay. So once you want to basically enter and store, okay, so what is required is you have to allocate memory, isn't it? So once user starts entering n number of elements, so you have to allocate memory, so which is using malloc you are allocating here, iptr is equal to, okay, so type conversion here, and then using malloc of, I'm allocating n locations, and each location is of integer data type, so this is size of integer, okay. So once the memory is allocated, now we are able to store here, so that is iptr plus I, okay. So this is how you can store here, and then now we want to display these elements which are stored here, so I can just write a printf statement saying displaying elements. So in order to display elements you require again this for loop to iterate, okay, but printf statement to display the content, so %d, okay. To access the content inside it using star, you can access here iptr plus I, and finally we will deallocate the memory which is allocated using iptr, okay. So let's run this code and see the result. And you can see it is asking you to enter number of elements. I'm entering value as 5. Now I'm entering 10, 20, 30, 40, 50, okay. So the same elements are getting displayed here. If you want them to be displayed in some format, okay, then you can use this %40. So let us enter this time only 3 elements, okay, and those 3 elements are like 10, 20, 30. So you can observe we are displaying those three elements 10, 20, 30. So whatever n value that you are giving, those many contiguously allocated memory is created with the help of dynamic memory management function, which is malloc, and the pointer will be pointing to the first location. Okay, suppose this time I am entering enter number of elements as a 10. So let us suppose those 10 elements are like this. Okay, now you can see here displaying elements 1, 2, 3, 4 up to 10. All these elements are displayed here. Okay, now what happens when you are trying to deallocate first and then trying to access the content? Let us suppose I am replacing this statement. I am removing here and placing here. Okay, then what happens is you are not able to access that content. You can see, because the memory is allocated, but later you have deallocated the memory, right? So whatever content, some garbage values that are stored in those locations will get printed here. Okay, because you have allocated memory using malloc here, and later stored the content using pointer you have stored, and later immediately you have deallocated memory. Now you are trying to display the content. Okay, so in this case what happens, since it is already deallocated, okay, now you are trying to display in those locations, there will be some garbage values, so they will get printed. Okay, so that's why you must do this deallocation after your usage is completed. Okay, like this.